Somewhere, right now, a spacecraft that no longer exists is still teaching us things we don't understand. Think about that for a second. A machine that burned apart in an alien sky nearly a decade ago is still rewriting what we know about the solar system we live in. Nobody talks about this. Nobody explains why a single photograph, taken by a dying robot 400 million miles from Earth, quietly changed the story of our entire cosmic neighborhood. What you're about to hear is not a history lesson. It's a reconstruction of the final hours of one of the most important machines humanity ever built, and why the last things it ever saw are still shaping decisions being made about space exploration today. This is the story of Cassini's final images, and by the end of this, you will understand why scientists still call what happened next the goodbye that never really ended. To understand why this moment mattered, you have to go back to a decision made decades before it happened. In 1997, NASA, the European Space Agency, and the Italian Space Agency launched a spacecraft that almost nobody outside the scientific community paid attention to. It was called Cassini-Huygens. It weighed over 6 tons. It carried more instruments than any interplanetary probe before it. And its destination was a planet most people only knew from photographs and textbooks. Saturn, the ringed giant, 7 years away by rocket. But here's where it gets interesting. Nobody expected what that spacecraft would find. Nobody expected it to still be operating 13 years after arrival. And nobody, not even the engineers who built it, expected its death to become one of the most quietly emotional events in the history of space exploration. Cassini reached Saturn in 2004. From that moment forward, it became something closer to a resident than a visitor. It orbited the planet for over a decade, sending back data that reshaped textbooks, disproved assumptions, and revealed secrets that had been sitting in plain sight, 90-plus astronomical units away, waiting for something to finally look closely enough. But what most people don't realize is that Cassini wasn't just studying a planet, it was quietly building a case that would eventually force scientists to ask an uncomfortable question. Could there be life, or the conditions for life, hiding inside moons we had dismissed as frozen and dead? That question changed everything. Because here's what most people are not seeing when they picture Saturn. They picture rings, they picture a gas giant, they picture something beautiful but lifeless. What they don't picture is Enceladus, a small ice-covered moon that Cassini flew past dozens of times, and which turned out to be hiding something nobody expected. Beneath its frozen shell, Cassini's instruments detected geysers, plumes of water vapor and ice erupting from cracks near the moon's south pole, launching material into space. Read that again. A moon smaller than the state of Arizona was firing water into the vacuum of space like a cosmic geyser field. And that water wasn't just water. It contained organic molecules. It suggested a liquid ocean hidden under miles of ice, kept warm, possibly, by hydrothermal activity at the ocean floor. The same kind of environment where life on Earth may have first taken hold, in the deep, dark, mineral-rich vents at the bottom of our own oceans. This is where the story stops being about a planet and starts being about a possibility that changes how we think about our place in the universe. Because if a small, icy moon orbiting Saturn can hide a warm ocean and organic chemistry, then the odds that Earth is the only place capable of supporting life just got smaller, much smaller. And this is not speculation from a science fiction writer. This is what a spacecraft's mass spectrometer detected directly, by flying through those plumes and tasting the spray. Cassini didn't guess, it sampled, it measured, and what it found forced NASA's own scientists to reconsider where the next major mission should go looking for life beyond Earth. But Enceladus wasn't the only secret. There was also Titan, a moon larger than the planet Mercury wrapped in a thick orange atmosphere that hid its surface from every telescope pointed at it for decades. Cassini carried a passenger for this one, the Huygens probe, built by the European Space Agency, designed to do something no human-made object had ever done in the outer solar system. It was going to land. In January 2005, Huygens separated from Cassini and began a slow, controlled descent through Titan's thick atmosphere. And what it found waiting on the surface stunned scientists who had spent their careers preparing for this single moment. Rivers, lakes, seas, not of water. The temperature on Titan is nearly minus 200 degrees Celsius, far too cold for liquid water to exist on the surface, but of liquid methane and ethane. An alien hydrological cycle, complete with rain, evaporation, and flowing channels carved into the landscape, running on chemistry that has no equivalent anywhere else we've ever directly observed. Think about what that means. A world with weather. A world with a cycle of liquid, evaporation, and precipitation, just not with water. Titan is, in a strange and haunting way, one of the closest things in our solar system to another Earth, if you're willing to imagine an Earth built from entirely different chemistry. And Cassini didn't just glimpse this once. It orbited Saturn for 13 years, flying past Titan again and again, using radar to peer through the orange haze, mapping seas that stretched for hundreds of miles, discovering that some of Titan's lakes appeared to change over time, suggesting weather patterns still active today. Every discovery like this raised the stakes of what Cassini's mission actually meant. This was no longer a spacecraft sent to take pretty pictures of rings. This had become a mission that was quietly redefining where scientists believed life, or the ingredients for life, might exist. And that redefinition came with a cost. Because the more Cassini revealed about Enceladus and Titan, the more scientists at NASA became terrified of something most people would never think to worry about: contamination. Here's where it gets worse. By 2017, after 13 years in orbit, Cassini was running out of fuel. Not out of curiosity, not out of purpose. The spacecraft still had instruments working, still had questions it could answer, but its propellant, the fuel used to control its orientation and adjust its trajectory, was almost gone. And a spacecraft that cannot control its own path, drifting in an unpredictable orbit around a planet surrounded by pristine, potentially life-harboring moons, is not just a dead machine, it's a hazard. If Cassini had been left to drift, there was a real possibility, however small, that it could eventually crash into Enceladus or Titan. And if it did, it would bring with it something that could never be undone: Earth bacteria, microbial hitchhikers that survived the sterilization process, dormant for 2 decades, potentially waking up in an alien ocean and contaminating the very environment scientists were hoping to study for signs of native life. This is not chaos. This is strategy. NASA's planetary protection protocols exist for exactly this reason, because the last thing you want, after spending billions of dollars and 13 years searching for hints of extraterrestrial life, is to accidentally seed that life yourself and never be able to tell the difference between what you found and what you brought. So mission planners made a decision. And it's a decision that, when you really sit with it, is almost poetic in its brutality. They decided to kill their own spacecraft, deliberately, precisely, on a schedule, rather than let Cassini drift and risk contaminating a moon that might hold the answer to whether we are alone in the universe. They chose to send it into Saturn itself to burn up in the planet's atmosphere, erasing any risk permanently. They called it the grand finale, and it began in April 2017, 5 months before the actual end, with a maneuver that sent Cassini into a series of orbits nobody had ever attempted. 22 times, the spacecraft threaded a gap roughly 200 miles wide, the space between Saturn's outer atmosphere and the inner edge of its rings. No spacecraft had ever flown there. Engineers didn't know for certain if there was debris in that gap that could destroy Cassini on the first pass. They were flying blind through a region of space that existed only in theory. But here's the part that should make you pause. Every one of those 22 dives collected data that had never been possible to gather before. Cassini measured the mass of Saturn's rings with unprecedented precision. It sampled the material falling from the rings into the planet's atmosphere, revealing that Saturn's rings are, in cosmic terms, raining onto the planet, slowly disappearing over time. Read that again. Saturn's rings, the most iconic image in our solar system, the thing every child draws when they think of Saturn, are not permanent. They are actively raining into the planet, and someday, in a time frame measured in tens of millions of years, they may be gone entirely. This is where the tension in the story really tightens, because Cassini wasn't just approaching its own death. It was approaching the final chapter of a mission that had spent 13 years quietly discovering that almost everything in the Saturn system, the rings, the moons, the ocean beneath Enceladus's ice, was more fragile, more temporary, and more alive with possibility than anyone had assumed when the spacecraft launched in 1997. By September 2017, the fuel was almost completely spent. The final orbit had been calculated years in advance, adjusted and refined as engineers understood more about Saturn's gravity field, more about the ring particles, more about the risks of the descent. On September 11th, Cassini made one last distant flyby of Titan, the moon that had given it a gravitational nudge so many times before, shaping its trajectory throughout the mission. This time, Titan's gravity did something different. It bent Cassini's path just enough to guarantee that, on September 15th, the spacecraft would fall into Saturn and never come back out. But before that happened, Cassini had one more thing to do. On September 13th and 14th, as it coasted toward its final approach, the spacecraft's cameras turned back toward the system it had called home for over a decade, and it began taking pictures, not because scientists needed the data, not because there was some critical measurement left to collect. It captured these images simply because it could, and because the mission team wanted one last look. What most people are not seeing when they picture this moment is how deliberate and quiet it was. There was no drama in the control room. There was no last-minute crisis, just a spacecraft 400 million miles from Earth, slowly rotating its cameras across a system it would never see again and sending the pictures home. It photographed Saturn's northern hemisphere, swirling in pale gold and cream-colored bands. It photographed the rings, capturing a small moon called Daphnis carving wave patterns into the delicate structure of the Keeler gap, a feature so fine that most telescopes on Earth cannot resolve it. It photographed a lone propeller feature in the A-ring, a shape created by a tiny embedded moonlet trying, unsuccessfully, to carve open a gap in the ring material, a strange half-attempt at moon formation happening in real time. It photographed Titan one final time, its thick orange haze glowing faintly. It photographed Enceladus, the moon that had rewritten the mission's purpose, setting slowly behind Saturn's curved horizon, disappearing from view for the last time. And then, on September 14th, at a distance of roughly 394,000 miles from the planet, Cassini's cameras captured what would become its very last image. It's not a dramatic photograph. There are no explosions, no dazzling colors. It is a quiet, monochrome view of Saturn's night side, illuminated only by faint light reflected off the rings. And within that dim, grainy frame is the exact patch of atmosphere where, less than 24 hours later, the spacecraft itself would enter and disintegrate. Think about what that means. The last thing this spacecraft ever photographed was the precise location of its own death. It looked directly at the spot where it would cease to exist, and then it sent that photograph home before the moment arrived. This is where the emotional weight of the story becomes almost impossible to separate from the science. Linda Spilker, Cassini's project scientist, referred to this final collection of images afterward as the mission's scrapbook, the last entries in a photo album 13 years in the making. And once those images were transmitted, the cameras were powered down. There was nothing left for them to do. From that point forward, Cassini would rely entirely on its remaining instruments to gather one last kind of data, not visual, but chemical. On September 15, 2017, Cassini began its final descent into Saturn's atmosphere. This was the moment everything had been building toward. Not a crash, not an accident, but a carefully engineered ending. As the spacecraft plunged deeper, its small thrusters fought to keep its antenna pointed toward Earth for as long as physically possible, straining against the thickening atmosphere that was beginning to tear at its structure. And even as it was being torn apart, Cassini kept working. Its mass spectrometer sampled the composition of Saturn's upper atmosphere in real time, sending that data back across the solar system in the final minutes before contact was lost. This is not a machine simply falling. This is a machine choosing until its very last functioning second to keep doing the job it was built for. Somewhere in Saturn's atmosphere, at speeds and temperatures that would tear apart most spacecraft in seconds, Cassini burned up like a meteor. There was no wreckage to recover. There was no debris field to study. The spacecraft that had spent 13 years orbiting Saturn, that had flown through the plumes of an alien ocean, that had watched liquid methane rivers carve channels into an orange moon, that had photographed the fine architecture of Saturn's rings in more detail than any instrument before or since, simply ceased to exist, converted into vapor and scattered particles within the very planet it had spent over a decade studying. But here's where the story doesn't end, and this is the part almost nobody talks about. Cassini's death didn't stop the mission, it transformed it. The data collected during those final 22 orbits, and especially during the final plunge itself, is still being analyzed today, years after the spacecraft ceased to exist. The measurements of Saturn's rings raining into the atmosphere reshaped models of how planetary ring systems evolve and eventually disappear. The atmospheric composition data gathered in Cassini's last moments gave scientists their first direct sample of Saturn's upper atmosphere, information that could not have been obtained any other way, because no other mission has ever gotten close enough to try. And the images from Enceladus and Titan didn't just end the mission, they launched the next one. Because of what Cassini found, NASA is now developing a mission called Dragonfly, a rotorcraft lander designed to fly across Titan's surface, hopping from location to location, sampling the chemistry of that alien world directly, searching for the kind of prebiotic complexity that might tell us how close Titan really is to the conditions that gave rise to life on Earth. And because of what Cassini found at Enceladus, that small icy moon has become one of the most closely watched targets in the entire search for extraterrestrial life, discussed in the same breath as Europa, Jupiter's ice-covered moon, as one of the most promising places in our solar system to look for a second Genesis, a place where life may have arisen independently of Earth, using entirely different starting conditions, but arriving perhaps at a similar answer. What most people are not seeing is that Cassini's final images were never really about Cassini. They were the closing argument in a 13-year case the spacecraft had been building the entire time it orbited Saturn, a case that said, quietly but insistently, that this solar system is far stranger, far more dynamic, and far more potentially alive than we assumed before we sent a 6-ton robot on a 7-year journey to find out. And this is where everything changes in how you should think about that final photograph. The grainy, dark image of the exact spot where Cassini would die. It wasn't a farewell, it was a signature. A machine at the absolute end of its operational life, choosing to document the precise coordinates of its own ending, and trusting that somewhere, decades later, people would still be looking at that image and asking what it meant. According to mission scientists who worked on Cassini for its entire operational lifetime, the emotional impact of watching the signal disappear in the control room at NASA's Jet Propulsion Laboratory was unlike anything they had experienced in their careers. Grown scientists, engineers who had spent decades of their professional lives dedicated to a single spacecraft, described watching the live telemetry feed go flat with the same weight you might expect from losing something far more personal than a piece of hardware. Because in a very real sense, Cassini had stopped being just a machine to the people who worked on it. It had become something closer to a colleague, a distant, silent partner that had been sending letters home for 13 years, describing a world none of them would ever see with their own eyes. And here is the part that should genuinely unsettle you. Cassini's mission wasn't cut short by failure. It wasn't destroyed by malfunction or accident. It was killed deliberately by the very people who had spent their careers keeping it alive, because the discoveries it made were too important to risk contaminating. The spacecraft's death is, in the strangest possible way, proof of how significant its life's work had become. You don't sacrifice a 13-year mission with working instruments and remaining fuel unless what you're protecting is worth more than the mission itself. And what NASA was protecting was the possibility, however uncertain, however far from confirmed, that somewhere beneath the ice of Enceladus, or within the methane lakes of Titan, something is waiting to be found that would change the answer to the oldest question humanity has ever asked. Are we alone? That question is still unanswered. Dragonfly isn't scheduled to reach Titan until the 2030s. No mission has yet been sent to drill through Enceladus's ice and sample its ocean directly. The organic molecules Cassini detected in those geysers are consistent with the building blocks of life, but consistent is not the same as confirmed. Every discovery Cassini made raised the stakes of the next mission, without ever fully answering the question that made those discoveries so significant in the first place. So think about where that leaves us. A spacecraft spent 13 years circling a ringed planet 400 million miles from home, discovered oceans and rivers and rain on worlds that shouldn't have any of those things, took one last look at everything it had studied, photographed the exact location of its own death, and then disintegrated into the very planet it came to understand, all so that the moons it studied would remain untouched long enough for a future mission, built by people not yet born when Cassini launched, to finally answer the question it spent its entire existence circling but never quite reaching. What happens when Dragonfly lands on Titan and starts sampling that alien chemistry directly? What happens if a future mission drills into Enceladus's ice and finds something moving in that hidden ocean? And what does it say about us as a species that our answer to finding a potentially living world was not to rush toward it, but to destroy our own spacecraft rather than risk touching it the wrong way? Cassini's last photograph is still out there, sitting in NASA's archives, a dim and quiet image of a patch of atmosphere that no longer holds any trace of the machine that photographed it. But somewhere beyond that image, on a moon wrapped in orange haze, or beneath an ocean sealed under miles of ice, the real story Cassini started may still be waiting for someone else to finish. And nobody, not NASA, not the scientists who dedicated their lives to this mission, not anyone watching this right now, knows yet how that story ends.